Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from ISI MStat 2015, problem number 6 from the PSB section. So it says that suppose x1 through xn are IID random variables with mean mu and variance 1. Also assume that y1 through yn are IID with PMF this. This is the PMF of yi, which takes plus 1 and minus 1 with equal probability, and are independent of x1 through xn. Define Tn as follows. Tn is 1 by n summation yi into mod of xi. For any fixed real number z, find limit n tending to infinity probability root n times Tn less than equals z. So first let us focus on the first part. So given x1 through xn are IID, right, with mean mu and variance 1. Also y1 through yn are also IID with PMF this, and they're independent of x1 through xn. This is important. They are independent of x1 through xn. Therefore, expectation of yi is nothing but 0. We can easily calculate that. We have the PMF, and variance of yi is 1. So expectation and variance are known. They are very easy to calculate from the PMF, right? Now Tn is 1 by n summation yi into mod of xi. That means root n times Tn is summation yi into mod of xi by root over Tn, right? This is the root n times Tn. Summation I running from 1 to n yi into mod of xi by root n. That means since yi and xi's are all IID, that means y1 into mod of x1 by root n, y2 into mod of x2 by root n, and so on, yn into root mod of xn into by divided by root n. These individually are all IID random variables, right? These things, this one, this one, this one, and so on, following some distribution. We don't need to know about the distribution. We just need to know that they are IID. So that means root n into Tn, this is nothing but a sum of IID random variables, right? Now expectation of root n into Tn is nothing but summation expectation of this thing, which easily turns out to be 0 because we don't need to know the expectation of mod of xi, because the expectation of yi is 0. So the entire term turns out to be 0, this one, right? And variance of root over n into Tn is this one, which is easily calculatable. Expectation of yi square into xi square minus expectation of yi into mod xi whole square. Since xi's and yi's are independent, right? So it splits out, the expectation splits out into product terms. From there, you can easily find out that the variance of this thing is 1 plus mu square. Therefore, ultimately, variance of root n into Tn is 1 plus mu square, right? Because there was a summation before that and divided by n, so 1 plus mu square. Ultimately, it's 1 plus mu square. Now, coming back to the problem, limit n tending to infinity, probability root n into Tn less than equals z. We are standardizing the entire thing. This is a random variable, right? So standardizing it by subtracting the expectation of this thing and dividing the whole thing by its standard deviation. We have this entire thing, that means root n into Tn minus expectation of that divided by the standard deviation of that. This is the variance. So the root over 1 plus mu square is the standard deviation, right? So this entire thing is less than equals z by root over of 1 plus mu square. Now, by the central limit theorem, since it is under the effect of limit, by the central limit theorem, after standardizing, this entire thing becomes simply probability z less than equals z by root over 1 plus mu square, where z is the standard normal distribution. This entire thing converges in distribution to the distribution of standard normal distribution. That means it ultimately becomes capital phi of z by root over 1 plus mu square. Therefore, limit tending to infinity, probability root n into Tn is less than equals z is nothing but capital phi of z by root over of 1 plus mu square. This one. It's very easy. So all we needed to do was find out the expectation, standardize this form, and use the central limit theorem, or CLT for short. That's the only thing we needed to do. So this is true for all real number z. You can put any real number z. Now, if you remember, if z follows standard normal, then probability z greater than z alpha for some real number z alpha, where alpha is some real number between 0 and 1, probability z greater than z alpha is alpha. This is the upper cutoff point. This z alpha, this thing is called the upper cutoff point. It's alpha cutoff point. Upper alpha cutoff point. Now, therefore, capital phi of z alpha, capital phi of z alpha, which is probability z less than equal z alpha, is 1 minus alpha, right? Because probability z less than equal z alpha is 1 minus probability z greater than z alpha, this one. So it's ultimately capital phi of z alpha is nothing but 1 minus alpha. Now coming back to the original thing we just found out, limit n tending towards infinity, probability root n into tn is less than equals, replacing z by this thing. As I said, this is true for all real numbers z, so you can replace anything. You can put any real number z, any real number here in place of z. So replacing z by root over of 1 plus mu square into z alpha, we have capital phi of z alpha, which is nothing but 1 minus alpha. Therefore, probability root n into tn greater than this thing, greater than root over 1 plus mu square into z alpha is alpha, right? Because it just becomes 1 minus of this thing, so it becomes alpha, this thing, this entire thing. Coming back to the question, why I am doing this, coming back to the question, the first part is easily solved. It is capital phi of z by root over 1 plus mu square. It has already been solved. The second part says, using the result in part A above, find random quantities ln and un based on tn such that limit n tending towards infinity, probability ln is less than equals mu is less than equals un is equals to 0.95. That means we have to find out two random quantities ln and un such that the probability of mu lying between these random quantities is 0.95. That's why I'm doing this. So ultimately, probability, as I said, this thing greater than this thing is alpha. Now, just trying to make mu square as a subject, we have this just mu square as a subject, squaring these things and all that. This is limit n tending towards infinity. Probability mu square less than n into tn square by z alpha square minus 1 is alpha. Just it comes from here, making the mu as the subject. That means mu lies between, probability of mu lies between this minus root over of n tn square by z alpha square minus 1 and plus root over of ntn square by z alpha square minus 1 is alpha, right? This thing is true. Therefore, for alpha equals to 0.95, we have, we put alpha equals to 0.95, we have this entire probability equals to 0.95. That means this ln is nothing but minus root over of ntn square by z 0.9 alpha 0.95 square minus 1, and un is the positive version of this thing. This is the ln and this is the un. These are the random quantities that we needed to find. So probability of mu lying between these random quantities is 0.95, and these are based on Tn, right? Because z 0.95 can be found out from the chart of the standard normal distribution, right? This thing, and n is obviously should be given because n is the sample size, and Tn is also calculatable from the xis and ys. So entire thing is actually a statistic. So this entire ln and un can be found out, and they are based on Tn. So this is the solution of the second part. So the only thing he needed to do, it has already been stated actually that the using the result in part A above, it has already been given in the hint as a hint that we have to use this one, this result. We should be able to calculate something equals to this capital phi of, as I said, z by root over 1 plus mu square. After finding this out, you can use this result to find the next part. It's actually very easy, it's not difficult at all. So there you have it, the solution of this problem. See you till next time. Bye.